All right, hey everybody. I'm going to go ahead and do problem number 19 here. So if you would, jump into it with me. Looks like 8 marks here. Before I do so, I'd like for you to take a look at this expression here and notice that, yes, it is set up for an integrated factor form. However, here I've got 3 marks, indicator that there's something else going on. Doesn't look like it wants me to solve. It just wants me to get a general form. And so what I want you to do is pause the video and see if you can come up with an expression whose result is this, using the chain rule. Okay, so this is a chain rule reversal. So pause the video and then go ahead and come back and we'll talk through it. All right, so that expression actually is the derivative with respect to x of xy, right? If I use the chain rule on that, I get x times dy dx plus the derivative of x, which is 1 times y. So I'm going to do a replacement of that expression there with d dx of xy. I'm going to set that equal to f of x. All right, so the problem wants me to show this expression somehow. So I'm going to integrate both sides with respect to x. On the left side, when I integrate the derivative of xy with respect to x, I just get xy. And on the right, I just get, and I don't know what f of x is. I don't want to write the actual antiderivative because it's not what I'm looking for in the answer. So I'm going to leave it like that, and then I'm going to divide by x. Right on. There we go. We got what we wanted. All right, let's move ourselves down to part B. Let's use what we know from part A because I'm seeing something similar here. I've got this and I've got some function, and from above I see that y will equal 1 over x integral of f of x. Okay, if you're comfortable with heading with this, go ahead and try to complete the problem. However, please do not distribute the 1 over x into the integrand. So do not do this. Do not do this. This is incorrect, right? Normally we think, well, we want this variable to be in here. Not in this case. This form up here is telling us just to take 1 over x times whatever we get for the integral of f of x. Okay, so go ahead, pause the video if you'd like. I'm going to continue to work here. All right, I'm going to get 1 over x times the integral of x to the negative 1/2. Okay, so I get 2 square root x plus c. Okay, now I am given an initial condition of 4 comma 2. So I'm going to plug in a 2 for y. I'm going to plug in a 4 for x. And I'm going to solve for c. So that'll be 2 equals, that's going to be 1 plus c over 4 if I distribute. So it looks like I have to have 1 plus 1 to get 2, so c has to equal 4. All right, so that's going to give me a function y equals 1 over x 2 root x plus 4, or y equals 2 over root x plus 4 over x. All right, so there you have it. There's the solution to our differential equation using a somewhat abnormal method, but it looks pretty manageable. All right, guys, that's a quick 4-minute video on a method for solving differential equations. If you got questions, as you know, just shoot them to me and we can talk through it.